Hey everybody, this is Mr. Beckstrom, and today I want to take a look at example from 10.3. This is number 9, and this is in the section for the ellipse. It says find the center, foci, and vertices of the ellipse and graph the equation here. Alright, so like all of these, I kind of need to know what the formula looks like, and I have two formulas depending on whether the major axis is on the x-axis or is on the y-axis. Or so how do we tell which one it is? Well, they don't tell us which one is the major axis. So we're going to have to put it into the form and see which one is higher. If the value under this, the x term, is higher, then that means it's being stretched horizontally, and the x-axis is the major axis. If the larger value is going to be under our y squared term here, that means that this thing is being stretched vertically, and the y-axis will be our major axis. So how do we get it into the form to find out? Well, remember that this here needs to be 1 on both formulas. So the constant on the right needs to be 1. So I'm just going to go ahead and start off and just divide everything by 64 in order to get that to be a 1 here. So divide by 64 and divide by 64. All right, and this is going to give me the equation x minus 2 quantity squared all over 64, and I'm going to go ahead and write that as 8 squared so I can identify my a or b, plus, and 4 over 64 is 1 over 16, so we can write this as y plus 3 quantity squared all over 16, which I'm going to write that as 4 squared, is equal to 1. All right, now I'm looking to see which one has the larger value on the bottom, and it's the one under the x squared term, so that is going to be my major axis. That means this thing is being stretched horizontally. All right, so that means that this is going to be our A, and this 4 is going to be our B. Now, if the larger value is under the y squared term, then that would be our A. And the other one under basically the larger value here is going to be your A. All right. And we also have, we're going to need to know the foci of this, and that's going to be using the C points. So in order to find C, they give us an equation with the formulas that says B squared is equal to A squared minus C squared. A squared minus C squared. So B squared is just equal to 64. So this is going to be 64 is equal to, oh, wait, that's not right, is it? B squared, the B is the 4, so that's 16 is equal to A squared, which is 64 minus C squared. All right, and then I'm going to go ahead and solve for C squared. So I'll add it to both sides, and then I'll subtract the 16 from both sides. So I'll have C squared is equal to 64 minus 16, or start over here. C squared is equal to 48, and I take the square root of both sides. And remember, for A, B, and C, we're only looking at the positive values. So I don't need to look at plus and minus square root of 48. I just need to look at the positive version of that. Square root of 48, and that reduces to, we can factor that. We can pull a perfect square out. So 48 is 16 times 3. So I can take the square root of 16, which is 4. So this is going to end up being 4 root 3. So the C is how we're going to find the foci on this ellipse. All right, a lot of work here. So let's go ahead and start trying to graph this and see what it's going to look like here. So I'm just going to do a little makeshift graph over here. And the center is going to be HK. So our center of the ellipse is equal to HK. HK. So that means in this case, it's going to be, since there's a negative in the formula, you're just going to take the opposite sign of whatever's here. So that's going to be a +2 and a -3. So that's going to be 2, -3. That's our center. So I'm going to go 1, 2, 1, 2, 3. And this is the center of our ellipse. Now we can use A and B in order to find the left and right vertices of this ellipse as well. Or they call it the vertex right of center and vertex left of center. So we're going to use the A for that. The A is 8. That means we're going to go 8 units this way and 8 units that way in order to find basically the right and left end of this ellipse here. So if you take this value 2 and you add 8 to it, that's 3, 4, 5, 6, 7, 8, 9, 10. So it's going to go through this point here. And then we can also subtract 8 from that. So 1, 2, 3, 4, 5, 6, 7, 8. So that's at -6. You could also just do 2 minus 8, which is -6. And it's going to go through this point here. Now the top and the bottom use the B, so I can go up 4 units. So we're at -3, so up 4 units is going to be up to +1. And we also go down 4 units, so 1, 2, 3, 4. B is always going to be your minor axis. That's the one that's not being stretched here. So it's going to also go through this point here. And now I can just kind of draw a horrible ellipse here. Oh, that's not bad. That's actually probably one of my better ellipses. All right. And then the last thing we need to do is find the foci. So just like we used A to add and subtract and B to add and subtract, we're basically doing the same thing with the foci. Now the foci always lies on the major axis. The major axis is the x-axis, so it's going to go left and right. And here is C, so we're going to add and subtract this C value from the x value of the vertex to find our 2 foci points. Now, what is 4√3? Let's kind of get an idea so we can at least graph this, okay? So if I do 4 times the second square root of 3, second square root of 3, that is approximately 6, almost 7. It's almost 7. So that means if this is 8 units away, almost 7 is going to be like right here. And if this is 8 units away, almost 7 will be just like a unit closer. So it'll be like right here. So these are 2 foci points, and I can just write this like this. We know that the center is at 2, -3, so I can write it as 2 plus 4√3, -3. That is our foci on the right, and then the foci on the left is just going to be 2 minus 4√3, -3. And that should cover our 2 foci points. And that's pretty much it. And then the last thing they want you to do is just match the graph. And they give you like 4 of them. So it's going to be the one that's mainly in that 4th quadrant there, or where the center is in the 4th quadrant. And that's pretty much it. So if you have any questions, please let me know. And I hope everybody has a great rest of your week. Thanks.